So we are going to do ARMA 1.1 example. Last time we converted ARMA 1.1 to AR infinity.
And MA infinity.
We converted to MA infinity. That gave us, is it pi weights or psi weights?
Is it AR psi and MA pi, or did I reverse those again?
It's reversed. Pi weights, psi weights, pi values, psi values. So let's say we have an AR11 model. Oh, excuse me, I meant to say ARMA 1.1 model. I'll use xt minus 0.95 xt minus 1.
Professor, before we continue, will that actually work? Sometimes you create things that just ended up not working before.
I'm not sure.
Okay.
Which would imply that you have to take notes.
I was going to take the notes anyway, but.
So that is our ARMA 1.1 model, and I'm giving you this, and as always, epsilon c is normally distributed, mean 0, standard deviation 1. Of course, I could have mean 0, standard deviation sigma. I'm just using 0 and 1.
Could you also say that xt is equal to n0, 1? Or like you only have to do it for one of them?
It is the last week before, it's the last week of the semester. He just asked me a question. Could xt be normally distributed 0, 1?
Wait. Okay.
Could it? Absolutely not. This is noise. That is the process we're observing. That cannot be noise too.
This train just crashed.
So, we can write pi of b and theta of b.
Wait, why theta be not the okay, yeah, okay.
Brains go one step ahead of me. So, phi of b, what would it be?
Isn't that's the capital theta, and what was
Yes.
Okay.
I thought it would work if I made it bigger. So what is phi of b? By looking at it, you should know.
I'm probably going to reverse this again, but it's you got to pull out the x. No.
Xt minus 0.954. Or is it just 1 minus 0.95? Just 0.95.
Would you add an x?
Where is the p? Where is the p?
Oh, it's just 1 over 5.
Right. All I'm doing here is applying the backwards operator v times xt. And when I do that, it'll simply become xt minus 1. And theta of b,
1 minus 0.6b.
1 minus 0.6b. Of course, I could do phi of b divided by theta of b, theta of b divided by phi of b to find the pi weights, psi weights, and all that. But not necessary, because we derived an expression for the pi weights. We derived an expression for the psi weights. So let's see. So what I'm going to do is I'm just going to look at an AR model instead of going for an ARMA model. Of course, each model will have its own benefits, but in this class, I just want to see if we can rewrite the ARMA model that we have in terms of an AR model. So what is our AR infinity expansion? Pi 0.
Professor,
Yes.
out in like the real world, which one of these is like most commonly used? The MA, AR, or the ARMA?
AR. I mean, we like to use ARMA together, but MA models are typically harder to model compared to AR models. But both of them are doable.
And then ARMA is just sometimes needed, or
ARMA is a bit of the most part, especially if you want to do prediction, right? But the way we do it is if I observe a bunch of observations, say x1 through x10, if I subtract x10 minus x9, that is going to give me the change between x10 and x9, right? So the way to view that would be, okay, x10 happened from x9 with some noise added to it, right? So we can go looking for those successive differences and we can estimate the values of epsilon c. So you can then fit an MA model using that. But at the end of the day, our goal is to predict what would happen next in XT. So we can either use this side to do that, or we can use that side to do that. And eventually the noise will come together. If you take linear regression, we call those the residuals. So they will come into play. So that is our expression for AR infinity. And we know that the expression for pi 0, or pi naught, is always 1. What is pi 1? Based on what we derived? Is it phi 1 minus theta 1, or is it theta 1 minus phi 1?
I have negative, I think, phi or phi 1.
Pi 1, I would like to know for pi 1.
Yeah, that's what I'm looking at right now.
it's phi1 minus theta 1.
It's phi 1 minus
He's
theta 1.
looking at what he changed it to
Oh, yeah.
organize it further
Yeah.
later.
Right. Now, I could have generalized it from k equals 1, but I generalized it for k greater than or equal to 2. And that was minus 1 raised k minus 1 multiplied by just pi 1.
So, theta 1 k to minus 1 times pi 1.
What?
Theta. You ended
It should be phi 1 raised k.
Yeah, negative phi 1 raised k minus 1 pi 1. That's what I wrote down.
No, theta.
Theta 1 k minus 1 times pi.
Here's my notes from yesterday, not yesterday, Tuesday.
It's not feasible. There should be another K, or else we won't have recursion.
K minus 1 pi 1.
Right, I see what you're saying.
And then you can do, I guess, turn to
So this would be theta 1 raised K minus 1 multiplied
pi 1.
by pi 1.
Yeah.
Because we need recursion, if it's just pi 1, we'll end up getting the same answer. So, in order to go up to x t minus 4, I need the first 4 terms, correct? So I need the first 4 pi rays. So pi 0, always 1. Pi 1 is phi 1 minus theta 1. Phi 1 in our problem is 0.95. So 0.95 minus theta 1 minus 0.95 minus theta 1. The reason being, in our model, we use xt plus phi 1 xt minus 1 epsilon t plus theta 1 epsilon t minus 1. If you see minus in the model, this would just change in terms of signs, but the recursion equation will be very similar. So put those two together, we will get minus 0.35. Yes. Now we can move on to pi 2. Pi 2 is minus 1. 2 minus 1 is 1, so minus 1. Theta 1 raised k minus 1. Theta 1 is 0.6. Raised k minus 1. 2 minus 1 is 1. Multiplied by negative 0.35. So what do we get? Negative times negative positive, 0.6 times 0.35.
Wait, so would it be negative 0.6?
Okay. So negative 1 times negative 0.6 times negative 0.35.
Negative 0.21.
Pi 3 would be negative 1 raised k minus 1, which would be 3 minus 1, so 2, minus 0.6 raised 2, multiplied by minus 0.35. What do we get?
Negative 0.126.
Negative what?
0.126.
Pi 4 would be negative 1 raised 3, negative 0.6 raised 3, negative 0.35. What do we get?
Negative 0.0756.
Good. Now, I just want the first 4 terms because I'm doing sort of an approximation.
So we ignore pi 0, we just go with pi 1, pi 2, pi 3, pi 4.
No, we need pi 0, but we will ignore everything past that, past pi 4. So, epsilon t, when k is 0, we will have pi 0 times xt plus pi 1 times xt minus 1 pi 2 times xt minus 2 pi 3 times xt minus 3 plus pi 4 times xt. Yes? Pi 0 is always 1, so we have xt. Pi 1 is minus 0.35, so minus 0.35 xt minus 1. Pi 2 minus 0.21 xt minus 2. Pi 3 minus 0.126 xt minus 3. Pi 4 minus 0.076 xt minus 4. That looks very weird to me. The signs have to alternate. I think what's alternating? Negative 0.6 squared is positive.
Positive, positive, negative.
Negative times that is positive, okay. Negative times negative positive. Oh well. Okay. So epsilon thing ends up being that expression. Now, there is a concept of absolutely summable. In other words, we want to know if the series is causal, if it is stationary. Well, one way to recognize it is to look at the value of phi1, right? From an AR1 model, we know if phi1, the absolute value of phi1 is less than 1, then we have causality, yes? Which would result in stationarity.
That was from the last time we did the AR stuff, right?
Right. And if we have theta1 less than 1, we would have invertibility. That would imply stationarity. But I'm going to put here AR side and MA side because we're dealing with an ARMA model, right? If it is just AR, I can look at causal stationarity, end of story. If it is just MA, invertibility, stationarity, end of story. But since it is an ARMA model, both of these must be satisfied for us to have stationarity. Does that make sense? So in our case, both of them is true. What is another way of checking for stationarity? Using the AR infinity scenario.
Would it be if it's like geometric?
Okay, close.
Absolutely solid.
Absolutely solid. End of this semester, you guys should know that phrase pretty well. Absolutely thumbable simply means if I sum all the pi weights, their absolute values, that has to be less than infinity, right? In other words, the pi k values must converge to 0. So if k gets larger and larger and larger, pi k must be 0. Let's see if that is the case here.
By the way, was the epsilon t equals the xt minus all that? That was the AR4 line.
Yes, that is our AR4. Let's say if, in fact, it is absolutely summable. So both of these are equivalent conditions. So as k gets bigger and bigger, we want the pi values to be approaching zero. Give me two k values. One, say, between 100 and 200. The other between 1,000 and 2,000.
100 and 2,000.
I need two k values. Oh, you're saying nice in between.
Oh, you don't count those.
131 and I guess 252.
Yes, pi 131. If you plug that in, you'd have negative 1 raised 130 minus theta 1 raised 130 minus 0.35. Theta 1 in our case is 0.6. And what is happening? What is that value?
Will be like really close to zero.
What is that value? I got that part, it's going to be very close to zero. I just want to make a point, make a case.
5.05 to the negative 30th. Or negative 5.05.
Okay.
Or 06, whatever. Does it make
The next one, negative 1 raised 13 negative 1 minus 0.6 raised 13 negative 1 times minus 0.35.
It just gives 0. It doesn't, the calculator doesn't go that small.
Right? It worked right then. I just wanted to demonstrate that it is going to become 0. So what this tells us is beyond a certain value of k, terms become 0. Right? So you are adding pi values from 0 all the way up to infinity. But beyond a certain value, certain k, you're just adding zeros. Do you think that the series is absolutely summable? Yes, because let's say you add all the way up to pi 100, you get some number. And based on the pattern that I'm seeing, all of those would be 0, correct? When you take the absolute values and add them together, it will still be less than infinity. Absolutely summable. So, stationary. Yes.
If it's an infinite limit, how will the sum ever be less than infinity?
Okay, if you have 1 and you have like 1/2, then you add 1/3.
Yeah, they're less than.
Right. Harmonic series. Or if you just keep on adding,
I guess just seeing it in decimal form made it harder to rationalize.
yeah, if you have, say, 1.5 as one of the coefficients. 1.5, as you keep on raising to the power of some number, it's going to get bigger and bigger and bigger. So if it alternates, perhaps things could get cancelled, in which case we need an alternating series test. But typically, if it keeps on getting bigger, eventually it will get larger and larger, and you won't get a finite number. So what we are saying here is that the pi values converge to 0. If it happens, stationary. So AR infinity with concluded it is stationary. So if you convert an AR process, an ARMA 1 process to AR infinity, that is stationary, then the ARMA model is stationary. So the model that we have is stationary.
So you're saying, go ahead, if the ARMA model is stationary, as if it's absolutely summable, that we just said.
Yes, either in pi weight or psi weights. Because we converted the ARMA model to an AR infinity. And if I determine that AR infinity model is stationary, well, that came from the ARMA 1 model, right? So that has to be stationary also. Does that make sense?